Hi everyone, and welcome to the NESP National Environmental Science Program Climate Systems Hub webinar on Building for the Future, which is designing for tomorrow's climate instead of yesterday's. For those of you I haven't met, my name's Jackie Brown. I'm the lead for the NESP Climate Systems Hub, and today we're going to be talking about that despite the fact that we're all talking about homes and buildings being more energy efficient, healthy environments, we're actually still using historical weather files. So what used to happen to design our buildings. It doesn't even match our currently warmed climate, let alone the potential extremes we know are going to come into the future. And this really does leave us unprepared for the implications of warmer temperatures on things like thermal comfort, energy use and peak demand, particularly in those heat waves. But first, I'd like to acknowledge the Muanina people as the traditional custodians of Nipaluna and the Palawa as the ongoing custodians of Lutawita, where I'm joining you today. Now, I do encourage you to pop the lands of where you're joining from into the Q&A. And we pay respect to elders past and present, and I'd like to extend my respect to all Aboriginal and Torres Strait Islanders joining us today. We recognise the important role traditional knowledge plays in understanding Australia's climate. We know you're also all dialing from all across Australia, so please take a moment to think about the traditional owners from where you're joining from. Let's start with a few housekeeping notes. This webinar is being recorded. The link will be available from the NESP Climate Systems Hub website. And with a large panel like we've got today, you might like to follow along with captions. I prefer to read and listen at the same time. It helps me. If you want to turn on captions, if you go to more language and speech, then you can turn on live captions on this system. Please do ask questions. That can be done by typing them into the Q&A function, and we will try and address as many as we can later in the sessions, but get in early because we don't have time to answer them all. Now, let's set the scene and provide a bit of background about the webinars. If this is your first one, welcome. These webinars are designed to provide an opportunity for learning and interaction with a broad range of topics and experts. So it's not just the NESP research. We reach out broadly and get lots of different input into topics we know you're interested in. We've had a great range of presentations this year, and this is going to be another one. So let's jump into it. Today's webinar originates from a NESP Climate Systems Hub project that's just been completed. That project is known as Building for the Future. We're joined today by Ramona Della Posa, the project lead and Climate Systems Hub knowledge broker for the Hub. She works at UTAS. We also have Hub researchers David Hoffman and Surendra Ranaya, both from the Bureau of Meteorology. We have building simulation practitioners Steve Watson, the Managing Director for RED Sustainability Consultants, Chris Lockhart-Smith, Sustainability and Energy Efficiency Consultant and NatHERS Assessor at Echo Dweller, Ania Upadar, Senior Lecturer at UNSW, and Zengan Ren from the Energy Research Unit at CSIRO. So welcome everyone. It's a big panel because there's many aspects to this topic. But let's begin by going back to early 2024 when the project was first put together. And Ramona, you're the project lead. How did this project come about, and what was that challenge that you were presented with to begin with?
Thanks, Jackie. Well, as the knowledge broker for the Climate Systems Hub, my job is to ensure that our research supports decision-making that helps us to adapt to our changing climate. And this project came about when I was in discussions with the Australian government's residential and commercial building policy teams, because there's a growing awareness that, as you mentioned, houses designed and constructed today are likely to experience a warmer and more extreme climate that they were designed for. And this creates a significant risk with higher cooling demands, increased overheating, and reduced comfort for the people living in them. However, including future climate projections into weather files for building simulation and energy assessments is not straightforward. The first step required a genuine co-design approach that brought together the expertise of climate scientists, building simulation practitioners, and policy stakeholders. Our plan was to develop a new methodology. We had to create future weather files and then test them with mainly volunteer building simulation practitioners from both government and private organisations across Australia. And we're lucky to hear from some of those today.
Thanks, Ramona. So one of the advantages of working in the hub, it's quite dynamic, and so Ramona could pull together experts from a range of agencies to meet that challenge. Let's meet one of those now. Ania, you've been an advocate of this project from the start and volunteered to be involved. What did you see as being the potential of this project? Why does it matter?
Yeah, this project is really interesting because, like I have first-hand experience of heat living in Western Sydney, and I have done some research, the impact of heat on new development. And then that really shows the real challenge. And we all agree that the climate is changing, and the government has also acknowledged, about this climate change. But the problem is, as a designer, we would not able to really practice those things in our design because of the limitation in the regulatory tools. And that is the kind of thing which I really want it to be, demonstrated. And this project is all about putting those climate files for everyone to access and use it and demonstrate whether we can able to design energy efficient house for tomorrow and ensure they are heat resilient.
Cool. Thanks, Ania. So really important to have a look at this and then get it into those model assessments. Chris, you're an experienced NatHERS assessor. Firstly, can you tell us what is NatHERS? Because people have been throwing that acronym around. And why is that important that houses are designed to meet some sort of standard?
Okay, the NATA stands for the Nationwide House Energy Rating Scheme, and it's been running since 2004. It comprises two main parts: the National Construction Code, or the NCC, which is managed by the Australian Buildings Code Board, and the CSIRO's Cheneth engine. The NCC determines the compliance protocols for the scheme, while the Cheneth engine is used to stimulate the energy flows in the building to ensure that it meets the relevant compliance. Basically, it's a program to ensure houses are designed to be energy efficient, affordable to run, and to keep occupants happy and healthy.
Okay, so what are we already experiencing happen, and what would you like to see change around that?
Well, I've lived in the Lower Blue Mountains for the last 30 or so years, and I became aware that summers were getting hotter. And when I started looking at the Bureau of Meteorology data in detail, it became very clear that the frequency of extreme heat days had dramatically increased up to and including the 2019-20 summer. Since then, it's become warmer and higher humidity, a bit more like Brisbane when I used to live there back in the 80s. Working with Ania for some years back, we modeled future climate files and their impact. In that process, I modified the buildings to comply with the current star system current at that time for in the future climate files. However, when I then resimulated the modified buildings under the current NatHERS climate files, they failed. That was clearly a problem when trying to design for a future climate. So I see two clear problems with the existing protocols. One, it does not test resilience to extreme heat, potentially keeping occupants neither happy nor healthy. And secondly, it acts as potentially as a barrier to designs that are attempting to future-proof for a warmer climate. So I'd like to see an ability to use perhaps an alternative assessment pathway using future climate files, as well, in addition, a health assessment of the resilience of a building to extreme weather events.
Yeah, oh, that sounds pretty critical. Thanks, Chris. Let's bring in Steve now. So, Steve, I understand that you've tested the prototype with a particular focus on the heat waves. part of what Chris was talking about, and their effect on people inside the buildings. So when you ran it, what insights emerged when you tested it with the future climate files, and were there particular building designs or performance outcomes that were concerning you?
Thanks, Jackie. So yes, in the past, we haven't had the ability to assess buildings under extreme heat conditions. The current weather files we use to assess have typical conditions, which purposefully remove the extreme conditions, so do not allow consideration of those extreme conditions. So these new XMY or extreme meteorological year files do give us that possibility of assessing the response of dwellings during extreme heat waves under a future warmer climate. And so using that as in software in the research we're currently doing, we're running simulations on a series of dwelling types and townhouses and apartments, both under power off and power on conditions. So with the power off, we're trying to test, how the designs perform in a passive or free running sense. And then with the power on to see what happens in terms of peak energy load relating to cooling that's required to bring the dwellings back into the comfort zone during the heat wave. So essentially what we're seeing is that under future extreme conditions with the power out, we're seeing dwellings are overheating to potentially dangerous levels, particularly in the warmer climates of Australia, as you might expect. And look, after a couple of days of extreme heat, and if the temperature doesn't reduce overnight, the houses just cannot cool down, and it doesn't matter how good the design is to begin with.
Yes. Okay. So looking into the future, I mean, there's a whole lot of technical stuff, but in terms of people and what they're experiencing, what's really worrying you about heat waves and health into the future?
Well, given what it's sort of showing for us, particularly in the warm climates where the passive, even sort of passive house designs are not able to maintain comfort with the energy off, with the power off. So my main concern then leads to power outages. If we can't keep the power on, if we can keep the power on, then we've got a better chance of keeping people cool, safe, and alive. So I guess the other things to note is that in our research, we're looking at new homes. So these are homes that are built to current 2022 energy efficiency standards. So they're quite good quality buildings in a thermal sense, and they're homes that are probably more likely to be air conditioned to help maintain cooler temperatures under extreme conditions. But these homes really struggle once the power is out under these predicted extreme conditions. So in the back of my mind, I can't help but be even more concerned about all of the existing homes sort of built to lesser standards, less likely to be air conditioned, and those predicted extreme conditions are very likely to expose occupants to even greater heat stress than in these older homes.
Yeah, and I think when we talk about climate change, sometimes we just get caught up in the tropical cyclones and the winds and the extreme rainfall, but actually it's the heat that probably should be front of mind as one of the most dangerous things going into the future, because like all three of you have been talking about, when you then put the building lens on that, we're talking about people's lives, the quality of life and whether they stay alive through some of these more serious events. So let's jump now to David and Surendra from the Bureau of Meteorology and dig a bit into that climate data. David, so you're at the pointy end of the climate data in the project. What was your job in the project? What did you set out to do?
Yeah, thanks, Jackie. So I was responsible for the climate data side of the project. So that means selecting, processing, and quality controlling the climate projections, and then bringing them into a format that Surendra could subsequently use to create future weather files that could then be used reliably in building simulations.
So there's lots of climate projections out there. We do lots of talks about climate projections. Is it just a matter of downloading temperature and rainfall and plugging that into their building simulation model?
No, unfortunately, that's not possible. You can't simply download future temperature projections and the other variables and feed them straight into the building simulation model. In reality, there's a lot more involved in that. So first of all, climate models are designed to simulate the climate system and not to produce building relevant weather files. So the data is not in the right format. As an example, NetHost requires hourly variables for weather files that are not provided from all climate model outputs. And if possible, some of the variables have to be derived and converted into the format that is expected by the software. Also, bearing in mind the climate models have biases, so the raw model output shouldn't be used directly. In our project, we applied a bias adjustment technique that preserves the observed characteristics of the historical weather files and also adds the climate change signal from the future. And this method is superior to other methods that have been used previously in creating weather files for building simulation, like the morphing technique, which just is a simple mean bias adjustment, while we are considering the extremes. Working with hundreds of hourly weather files also meant that we encountered small inconsistencies and errors in both historical observation and the future climate projections, because data isn't perfect and they could have quite some effects on the resulting weather files. And these had to be systematically identified and resolved. And that's also where really the co-design process became invaluable. So working closely together throughout the project, we were able to identify issues and refine the methodology to produce a data set that's both scientifically robust and also practical for the end users. As an example, we found issues with the cloud cover data. And as climate scientists, we tried to fix this from a meteorological perspective by recreating it using radiation components. But Zheng and Ren then pointed out to us that nighttime cloud cover was actually particularly important for building energy modeling. So our approach didn't work here. And this is kind of one example that's changed how we generated the weather files.
That always seems to be the case. It looks on the outside to be really straightforward. I will just get the climate and we'll put it in. But the more you dig into it, there's all these nuances and complexities to deal with that really blow the project out and make it more complex. So it's been great to see this team come together to answer some of those challenges. So David's got the data and curated it. Then that data is passed over to Surendra, also from the Bureau of Meteorology. So Surendra, once David had given you that data, then could we plug it into the building model?
Oh, thanks for that question, Jackie. My short answer is no. It wasn't ready to plug in. The data that David basically prepared, represented different 20 years of historical and future climate periods. But as David also mentioned, that the substantial work was still required before it could be used in building simulations. For example, there wasn't any established framework to translate this climate data set to weather files suitable for building modeling applications. So I developed a new methods that integrate these future projections from regional climate models with historical observations and produce typical meteorological year and extreme meteorological year weather files. And for the first time, basically, we developed a methodology to identify heat waves based on three key characteristics: the intensity, severity, and duration. So using this approach, we produced three XMY files: the most intense, most severe, and the longest durations heat wave conditions out of those 20-year periods. And these files, as Steve mentioned, can be used for stress testings for the buildings, assessing overheating, informing equipment sizing, and even estimating kind of peak energy demand. So I think in our terms, a key innovation was using different models, as David mentioned, that we use 7 different models that could represent, rather than one single model. Now these ensemble of models represent a range of likely climate outcomes. Then any designer can use that to, with a greater confidence and evaluate how the future building will perform. Or how the building will perform in the future. And one of the major part of my work was also ensuring that these weather files are fit for purpose. So what that means is that these files are scientifically credible, technically robust, and compatible with these building simulations tools. And finally, I think these methods that we developed is a data agnostic, basically. So that is this framework that we have developed can be applied to data sets from other climate, regional climate projections as well as even if the future generations of climate models we will have. So without having to redesign the entire approach, we would be able to apply these methods. Yeah, thank you.
Good. I love to hear that it can be repurposed and reused and we don't have to reinvent the wheel every time. But for someone starting out in this sort of field or something similar where they want to take climate data, what I'm hearing is you can't just go pick your favourite model and download a data set. You need to get a whole range of them. You need to understand the models and the biases and the complexities. The fact that the model you want to put it into will want different variables to what the climate model is going to put out. And even then you need to look at what that building model or whatever it is sensitive to understand how the climate model is telling it what is going to happen into the future. So lots and lots of layers there to consider, but it can be done, and it can be done. So there's a nice methodology to follow. So let's move to the next step. We've got the climate data. Then Zengen, moving to you. So I understand you then tested those weather files and simulated them with a range of standard house types. So what did you see were the implications of that future climate to the building performance in the future? Was there anything that jumped out as a surprise?
Jax, yeah. Since I joined CSO, around 20 years ago, I worked in the gender engine, how to improve the engine, and also as a CSO technical leader, I lead the development of two benchmark tools for new home and existing home. So climate finance is always the issues we want to look at, not just use the history and also want to look at the future. So for this project, I'm interested. So I have conducted the thermal performance. You saw the benchmark tool, look at the thermal performance like the star rating, and also look at the heating and cooling load, and also use the XMI extreme weather fire, look at the discomfort and our heat issues. So from all the studies, we got a lot of the detail that I don't want to, but overall, the result indicated the uncertainties associated because this weather fire uses 7 different GCM models. So the uncertainty is large than the difference between the CSO have already used mathematics to develop the future weather fire. And we compare this, the difference is larger than the average compared to CSO. So that means we need to look at carefully which model we should look. And another is good to me. Previously, we CSO the weather fire is current, the future is only typical or nearby, but now we have extreme, 3 different extreme weather fire. That's very important. I think if the future regulation or policy look at it, not just energy star radius performance, or also look at our heat issues, this kind of extreme weather is already important. So if you, for example, if you want to look at the summer comfort and the peak demand for the grid, that this is very useful for the extreme weather fire. And another is, we from this project that I involved in, and I look at it maybe in the future how to use part of history and the part of the future. The weather fire we can be, using. So I think the one impressed to me. So we have 3 different type of extreme weather fire, not just one. So we so 3 different. So this may be for different purpose. You will look at it, angles different. Yeah, this is most of it from my understanding. Thank you.
Thanks, Zengen. So Zengen showed that the testing showed the future building performance is very sensitive to the warming temperatures, increasing heat wave frequency, and that those building performance assessments have substantial variation across climate models and emission scenarios. So the choice of the model matters to what you're getting out there. So let's circle back now to Chris. How can you as a practitioner deal with this uncertainty and range of possible climate futures in the building simulation results? How do you overcome that?
Okay, well, there's kind of 3 different ways to look at that, guys. It's important to note that there may well be very significant differences in approach in how one designs for a hot, humid climate compared to a hot, dry climate, for example. You only have to look at the vernacular architecture around the world to see the different approaches. At one end, Darwin sits an extreme and faces real challenges that may require a fundamentally different approach in building design to ensure the health of occupants. The human physiology is much better adapted to extreme cold than to an extreme heat. And if a wet bulb temperature exceeds 35 degrees centigrade, sweat can no longer evaporate. This places humans in very significant danger. So I see resilience as a key metric to look at in hot, humid climates. So that's one aspect. When we're looking at mixed climates, the basic design approach to dealing with either a hot, humid or a hot, dry will not necessarily be impacted by the different models. However, in mixed climates, the predicted need for warming is potentially problematic. If the climate model still requires a significant warming demand, this may act as a brake on some of the design measures to reduce cooling demand, which is something that I've highlighted earlier. One possible way to address this is to remove the heating caps specified for compliance, and this will allow the design to be biased towards reducing cooling demand without penalizing it overall. For climates that are currently heating dominated is generally good news in that they will become generally more efficient, although they still will be susceptible to overheating events.
Sounds like there's a few different levers you can pull depending on where you are, and you don't want to pull one too much if it affects the other one. So it's a local discussion. I've still got a few more questions, but don't forget to put your questions in the Q&A if you have any, and we'll get to those at the end. But I want to move to Ania now, or back to Ania. We've got some momentum started through this project. We've got some early results and guidelines. What do you think the next steps are for making us more resilient in the future?
Now we have climate files, which is great news because and a different variety of climate files that we got. So it's just time to really look at it in more, like the simple way. And because we all know these are numerical values in a file, it would be good to have these data presented in a graphical way so that the wider audience can understand what are we talking. Say, for example, shift in the climate. Chris has already mentioned about how we are, going from heating dominated to cooling dominated, and it won't happen just overnight. It will happen, over time. So particularly if you look at in Sydney's climate, in the past it was, heating dominated, and currently we kind of feel like it is balanced. Going into the future, it will be more like cooling dominated by 2050. So that means this needs to be communicated very effectively to all its stakeholders. And I think that will help policy planners to also think about these things in very simple way to understand. And from there, what I would really like to see is these things is integrated in the policy. So we have the cycles of NCC change. So in the next round of NCC upgrade, maybe this needs to be, integrated. At least we can start with near future, 2030, kind of like the starting point, and then allowing future, 2050 or 2070 to add a kind of stress test and so those type of things. So from this point onwards, I would like a little bit momentum going towards putting this in our policy documents.
Yeah, thanks, Ania. And I'm based in Hobart, so most of our conversations are always how to warm the place up. But as we get more recently, the hotter summers, Tasmanians are going, oh, an air conditioner, what's that? Something to cool things down. It's a bit of a shock and something to keep in mind in the future. Let's go to Steve. So we've talked about these future climate data sets becoming more available and more accessible. How do you see the building simulation practice evolving over the next decade, particularly in relation to that energy efficiency aspect, occupancy comfort, and resilience, of course, in the extreme heat events?
Yeah, thanks, Jackie. Look, I definitely see that we could end up with house designs that are maladapted to future conditions if we're not providing the right thermal, simulation advice. So I see, potential of dual simulations where we're using typical weather files to assess heating and cooling loads and energy efficiency over the whole year, while then also potentially using the XMY, the extreme files, to assess occupant comfort, heat stress and safety. So this then suggests, the potential to introduce a new heat stress metric into the National Construction Code as a provision separate from energy efficiency. Energy efficiency currently assessed by NATA's assessments, and such a new provision might well sit under the health and amenity section, for example, which also have other health-related issues such as condensation management. We've got energy efficiency for residential buildings now well covered by the new whole of home energy efficiency assessment, which has been in place since the introduction of NCC 2022, and that factors in the efficiency of heating and cooling systems, hot water, lighting, appliances, PV, batteries, etc. So that's doing a really good job of capturing, home energy efficiency. So perhaps, in my thinking, perhaps the thermal performance assessment and heating and cooling load limits could potentially be used to focus in more on occupant comfort and safety from these extreme heat conditions. And so, maybe this takes some form of new heat stress indicator that we can use alongside energy efficiency.
Yeah, and you could see that becoming really relevant to vulnerable communities, your aged care, where it really will matter how they look at those purchases and the implications. Great idea. Let's go back to Ramona, who's been coordinating this whole effort and co-designing and getting everyone talking to each other to try and get it moving in a straight line, because there's lots of we've got this, but I need this sort of conversations. A lot's been achieved here, Ramona. It doesn't feel like it because it always feels so messy and complex and how do we get it to work and this won't work, but it's actually achieved quite a bit. I think, you've made a huge step forward. Well done. As a project leader, though, I'm sure you've got a huge shopping list of opportunities of things to do next. What do you think the next step should be?
Thank you. Yes, Jackie, you already outlined. I think, we've made an important step towards bridging the gap between climate science and adaptation in the built environment. We've got fit for purpose future weather files that we can test now that allow us to assess for the first time how homes will perform under warmer conditions, as well as, the more severe heat waves that are really important. But yes, there's more work to do. So when we tested the files, we've outlined that there's a big range in the results that you get for building performance, depending on which climate model you choose, which emissions pathway. So we really need to think about the choices that we're making, but to inform that choice, more work needs to be done. To guide that, we need to continue this collaboration that we started. We need to continue to test the file so that we can develop guidance on how this additional climate information should be used in practice. Agree, like Chris said, we could use an alternative future, but we need to agree on what best aspects of that, that future will inform the design response. So looking ahead, I think a long-term partnership with climate scientists and building practitioners, as well as policymakers, will be critical to building a national capability. And this would enable us to continually improve the input of the data, the updates to the future of climate files, and also understand, what's most important for building simulation so that we can develop practical frameworks and specific guidance for their application. This would also allow us to expand our work into commercial applications. We've only looked at residential applications here. We need to include other variables such as changes to precipitation and humid heat events has been outlined. That's really important for commercial applications. We also need to think about, improving the capability, as we said, so that we can continue to update and go forward as we get better information on these important aspects. We all need a safe and comfortable home. So by working together, I hope we can ensure that we're designing Australia's buildings for tomorrow's climate and not yesterday's through this work that we started. So
I think it's an excellent ambition, Ramona, and we're all on the same page there to make that happen. We can't afford not to. What a waste of money to not do that. There's a question coming in, actually there's quite a few questions coming in from Cameron Wilson, who's keen to take advantage of some of these climate data files and start using them. He says, are the new future climate files already available? Could you please share a link to the resource? Excited to see we don't have to develop such data individually and we can use this resource for consistency and modelling. That's fabulous. Consistency would be great effort in our climate community. Are we ready to share the data, Ramona?
Yes, for research purposes, we are willing to share the files. So we don't have a publicly available link today, but we will very soon. So we can, if you just will note down that question and we'll be in touch and we can provide, they will be available through the National Climate National Computing Infrastructure. Will have a NESP Climate Systems Hub data repository that you can download them from for the next 5 years. They'll be available for research purposes, because we are a research project. We're not providing these with the support ongoing, but we would really like to see keep in touch and understand how they're being applied.
Yeah, thanks, Ramona. So the next step after that, I've got a question for Anil.
Can I add on a little bit on that, Ramona? Sorry. Yeah, just to clarify that this is just prototype files only for the 11 locations across Australia, the major cities, and for 3 future periods. So of course, these files will be freely available for the research purpose. Sorry.
Yeah, cool.
Thank you, Serena.
Yeah. Ania or Steve or Chris, question for you. What kind of information or climate files do the building designers specifically need to build future-proof houses? So can you talk a bit about the climate data, I guess, that you want to know about? Can we get a bit more granularity on those factors? Who wants to
go for it, Chris? You look like you're about to talk.
Yeah, okay. Well, we basically we don't delve into the granulation of each climate file as a NAT as assessor, but basically what you're looking for is the sort of things that have been outlined, the temperature and humidity and things like this, so that we have an idea of how the climate has changed. I guess that's basically whatever changes that are existing can then inform the decisions we make in terms of trying to adapt to that climate. So we don't as assessors actually, we're not like researchers in that sense that we would be going into the granular detail, but we just need a file which can represent what we think is coming on the horizon, so that we can then try and adapt the buildings to meet those challenges. I hope that answers the question.
Sure. I'm going to dig a bit more into the heat waves. So there's a question here, Surendra, that there's different heatwave scenarios in the files you were talking about, but then the Bureau has heatwave forecasting categories. Are these the same thing?
Oh, that's a really good question. the short answer is no, not directly. So Bureau uses a different definitions for the heat wave. They use the excess heat factor, which is designed for forecasting and communications of heat wave conditions and for their potential impacts on the communities. However, for this project, our objective was a bit different. We needed a methodology that could identify heat waves event most relevant to building performance and resilience. And that's what through the CSIRO research came out. They needed 3 different heat wave files based on the intensity, severity, and the durations. And that's what we adopted in this.
Yeah. Thank you, Surendra. I've got a question myself just to follow that up. Let's just think about, if we go back to the raw heat waves, how are they changing in the future? What are we actually expecting from heat waves in the future? Surendra or even David?
I can start and David can add up because David has analyzed to all the 11 locations. If I have to say just for the Sydney, so what our data shows for the historical period from 1995 to 2014, we have experienced 2 heat waves, and the most intense and the longest and most severe was a 2011 case. Basically, the heat wave was 6 days of durations and intensity was just 33 degrees centigrade. But if you just look for the 2050, just from one model, what we have seen is that the number of heat waves from 2040 to 2060 has increased by 12 times, from 2 to 24. The durations had just increased from 6 days to 12 days according to that model. But there is again a range for that one, and intensity also increased by plus 2.7 degrees centigrade. And I think David has analyzed across all the stations. He could add up more on that.
Yeah, maybe just a few more points. So you summarized it already quite nicely. So, I mean, the direction that all 3 heatwave characteristics are taking into the future are pretty unidirectional. It's all going up in terms of intensity, duration, and frequency as well as severity. So this is all going up, and also depends very much on the emission scenario that we're looking at. So high emission scenarios leads to more extreme heat than the lower emission scenario. So if we're tracking that pathway, we definitely see a huge increase in some locations, specifically towards the end of the century.
Thank you. So thinking about that, there's a question here from Debbie Firestone. Can the modelling be applied at an LGA level to help compare the costs, benefits and effectiveness of improving thermal comfort of existing homes? So can we bring it down locally? This would help our understanding of key climate adaptation risk for our Tweed Bundjalung community and contribute to emissions reduction targets and forecasting for heating and cooling load demand. So a question about scale. Ramona, did you want to start?
Yeah, I can start, thanks, and get perhaps David to elaborate, or Surendra. They are the NADAS zone, so we've used, so importantly in this project, maybe hasn't been said well, is that the NADAS team and the commercial side of the Australian government were involved in this project as well. So we really wanted to, we are a research project, we're not we're not developing policy for them, but we wanted to make sure that we were including what they needed. So we aligned with the NADAS climate zones that are currently available. So it was, operational and similar. So it can be used at local government levels. What's important to understand is that because of the way we develop the files, they don't include things like the urban heat island effect. So if when you really drill down, we are using the weather station that's closest, and that could be, several hundred, a long way away, several hundred kilometres in some instances away from the site that you're looking at. So you've got, and also we have the climate models, which, David explained, that are at that high resolution. We are, like Surendra mentioned, we can use it with other data. So while we're getting those 4-kilometre climate convective permitting downscale projections that are becoming more available, we might, you can better represent those local features, but still, that has to be taken into account. David or Surendra, do you want to add to that?
Can I say something here? So for letters, yeah, I think in Australia there are around 537 LGA. So currently we are just group for each wildfire, which the LGA belong to this letters in the climate zone. So in the future, I think that this is if the future wildfire plugin, definitely the NEDAS tools can be plugged in, because currently we are just working on these the LGA levels. So how to the recommendation for the current the leach field or the future, something like that. I think this is very useful. Yeah, in the future maybe at these levels. Yeah.
Thanks, Sengen.
Yeah, just
Mhm.
can I add a little bit on that too? As mentioned by Renjen, our methodology depends on the historically available weather data as well, hourly data. So it uses from 1995 to 2014. So currently we don't have that data available at LGA levels, only at the NatHERS scales. Just to add on that, so there is a limitations to get it into the LGA level. We were looking other avenue as well, using the reanalysis product and other things. So that would be our future directions to look around.
So some questions have come in about which locations were tested and whether Perth was one of them. Did you have a set number of locations and what were they? Anyone? Is that Sengen? Did you do testing or Andra?
Yeah, so we have a Perth CBD. We have a Melbourne, Adelaide, Hobart, Canberra, Longreach, Cairns, Brisbane, and Darwin.
Mhm.
Have I missed anything, David?
I think so.
Mildura.
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 Oh, thank you, Steve. Yeah, so 11 locations.
Thank you. So not Perth.
Yeah, no, we have a Perth.
Say Perth. Okay, good. Got to have a West Australian one there. We'll be in trouble. Very important. Okay, next question then from Peter Butler. I think this is probably for Anir or Chris. We've talked a bit about what to do in new builds. Standard specifications can improve the climate resilience of new builds, but what could actually be done about the existing housing stock, which is potentially suboptimal? Do we just give up or what do we do?
I think this data will also help you to, when you try to, like retrofit or improve the performance of your building, you use, rather than, like using historical, you can use the future climate data and you can remodel your house and see how you convert it into more effective or more efficient for heat resilient aspect. So CSIRO just released, the tool for existing homes. So there's a potential to, plug in this new weather data and help them to suggest, how they can make these houses, the renovations more heat resilient.
Yeah, I think the tool we just significantly improved for this month released. So that we basically, look at the tool works on here's the current situation after you've done the simulations. And then we'll give you some general suggestions, which different locations, different suggestions, how to retrofit your houses. But currently, just based on, we have two functions. One look at the star rating, another is like whole house energy rating. That's considered as a previous, you all have mentioned, not just the building envelope performance, and also look at the solar PV, battery, and that stuff together. So we look at the house rating. So we have both these. But currently, we have no NCC or another regulations how to recommend that. Say, for this house, for thermal performance, we must achieve a 5-star, 4-star, and then based on that, or look at it, we wanted a full house, what is the energy cost of what is, but currently still have no this kind of guideline or regulations to the, maybe, I'm not sure, maybe they will release the next level, next NCC or something like that. But currently we have no this, but the tool is already the market for the player to play it. But for the weathers, we still use the RMI, TMI for based on the history, not the future. So this is maybe an area we also want to look at. After this project, maybe another project that we can get to some conclusion, and for not just 11 the climate zone, look at all there's 83 climate zone. So that's what where we can be generally what is across this country, what we can do for new home and the existing home, not just another starlight. It's also look at another NCC work like a condensation, indoor air quality, and heat exchange. All these kind of things, maybe step by step. I think that will be using kind of and weather fire. Yeah.
Thanks, Dingan. The next question is a long one, but it goes into regulation. So I'd like to unpack this. As building scientists, with the help of advancements in future climate data, we can test and predict building performance under future climate scenarios. Although these predictions are not perfectly accurate, they still provide valuable insights into potential risks and adaptation needs. I believe NatHERS could play a key role in shifting the current approach from energy efficient towards climate resilience and climate-proof buildings. Yes, I hope so. That's a good goal for us. However, I wonder what new regulations we should expect in the future, considering that climate resilience is highly location specific and requires locally adapted solutions. So the question is, do you see any regulations changing, and how would we manage these when they're so location specific? Who wants to take that? One's a bit curlier.
I'll start out.
Yeah.
I'll start out. Somebody else might want to join in. I mean, the way the NatHERS star bands work, it already is taking into consideration those sort of regional variations. So, you know, the Darwin requirements have a different amount of, or in that case, cooling load that's allowable. You go down to Hobart, the opposite end of the country, and it's all about heating, and so that's reflected in the code currently. So I don't see it as a massive step to introduce that sort of same regional approach when you're looking at either future, climate files or heat wave or heat stress kind of metrics. I think no matter what, Australia is such a big climate, you're going to have some sort of regionally adapted approach. Yeah,
cool. Thanks, Steve. And that brings us to, this is more of a political question, I guess, but every second news story at the moment is about the housing crisis in Australia. Even my kids who haven't even left home are worried about how they're going to get a house, and I hope they get a house. I'd really like them to move out. They talk about the needing to reduce regulations and build faster and be ready for the future. How are we going to work with that? Does that message align with the learnings here to sort of slow down and take time to consider future climate on building structures? Do you see a conflict, or what do we do about that? Ania, maybe? Do you want to try that one?
Yeah, thank you, Jackie. That's a very pertinent question. And for me as a designer, I would not really see that a really big challenge. Say, for example, if we are like CSIRO produce really good, like the platform where you can go and see, or I think BOM has got this climate analogous, so it predicts, like in future, maybe Sydney is pretty much like mimicking like Brisbane's climate, which is true. So that means people are still building in Brisbane. So that means we just need to learn. I don't think that would be a big issue. It's just like we need to know what is our priority. So the priority is now maybe heat mitigation. And if we adopt that from the beginning, I don't think that would be a big problem. But most important is what we build today needs to perform well today. And it will perform well in future as well. So we can't really expect an energy efficient house of today built, like a design with yesterday's climate. That means it doesn't really work, and forget about the future. It would not really work. So we just need to make sure we understand what we are aiming for and plan for that particular context within the design from the beginning.
That makes sense, Ania. Thank you. So we've done all this work, but we we want to see it have impact and change the regulations. Does anyone have a vision of how do we, I'm paraphrasing a question from Tanya Rowe, whose job is it now to take this information and try and get those regulations changed? Because I imagine that's not straightforward either.
Well, I think basically it comes down to the NCC, because they're the body that, or the Australian Building Codes Board, which determine these aspects. But I think that in some ways I would encourage there to be a little bit more flexibility in the approach, so that I kind of highlighted that earlier. But I feel that if we make everything too prescriptive, it can actually act as a barrier. And I think we need to recognize that things are changing, and one way of adapting to that change is to be a little bit more flexible about how we assess buildings. Not necessarily to assume that we're going to have lower standards, but just that allow people to make decisions about how they're going to try and design their buildings for the future.
Yeah, that's a good point to end on, and we're running out of time. Thank you. Thank you so much for such fantastic presentations to all of you, for your all of our presenters and our audience for their questions coming through. Thank you all for supporting the Climate Systems Hub once again. We hope you've taken something from today, be that learnings, connections with others in the space, or even just a wish to stay more involved in these discussions. We've got some great webinars lined up for the rest of the year, so do subscribe to our newsletter and keep an eye on your inbox for more information about what's coming up, and let everyone know how much fun they are. Please register also for our monthly newsletter, where you can get more information about some of our results and fact sheets and other webinars. And you're also welcome to fill in the short survey on how you found today. That's going to be emailed to you shortly. Thanks again to our presenters, and for those behind the scenes that have been making all of this happen and feeding me the questions as they come in. I've really enjoyed this, and I've learned a lot on quite a complex topic. So thank you everyone for making that simple to understand in quite a complex system. See you all later.
Thank you.